So let's see here. I'll start over there. Let me begin with a word of prayer. So, dear Heavenly Father, we thank you for this day. I thank you for your many blessings to us. We thank you that you loved us while we were yet sinners, that you died for us, that it's not because of our righteousness, but yours, that we can have salvation. And we just thank you for your grace and mercy to us each and every day. And I just pray you guide our steps today. Help us to glorify you in what we do, Lord. In your name I pray. Amen. Okay, so are there any questions about homework? I think there's something I should talk about in here because I talked about it in the Wednesday video, like last week, right? And a lot of you watched that, right? Some of you watched it carefully, some of you less carefully. So I think it'd be good for me to talk about the material in there again, right? I think, pretty sure. So let's talk about a theorem. And the thing that I haven't given a lot of airtime yet to in here is the issue of complex zeros. Complex zeros. And so there is a theorem about complex zeros that we should know about, and we need to be aware of it because it is I would say it's not entirely intuitive, but it's extremely useful for the problem. If there's a problem which is testing on your understanding of this theorem, not knowing it is really detrimental. Yeah.
I just couldn't do it. Yeah, it's not.
Your top hat's not working? Huh. Well, I don't know.
Yeah, mine's only been working on my computer. Like, it's not working on my phone, but it's working on my computer.
Okay. Then don't worry about it. So
Sometimes you can't do it all that.
let's take a break from the top hat here. So theorem, f of x. Thank you for bringing that to my attention. If you're so what I'm going to do is in the next participation period, I am just going to assume that if you have, like a couple of top hats for that period, you've been attending the whole time, all right? So as long as you have, let's say, 3 attendances counted since test 1, you will not be penalized, all right? You're like, oh, that means I can skip class until test. I mean, okay, fine, you can, but why would you? Because what's up? What's left? We have what? Today, Monday, and then next Wednesday is what? Quiz 2, right? Then you got your Friday and Monday after that, and then there's test 2, right? So if you really understand all the material, it's okay to skip these classes, honestly, for you. But you know who you are, and many of you that comment does not apply to, right? So let's get into it. If f of x is a real polynomial, what's that mean? That just means that all of the coefficients are real numbers, okay? And f of alpha plus I beta is equal to 0, where alpha and beta are real numbers, and beta is not equal to 0, all right? Then a few different things happen. One of the things that happens is alpha minus I beta must also be equal to 0, all right? So one of the things I can tell you is that if you have a complex 0, it comes with a conjugate pair, all right? So like you can flip the I to minus I and it's still a 0. That's one thing. Also, we have factor of f of x below. So the factor that we get is x minus alpha. So let's look at this. If you have alpha plus I beta, the factor theorem tells you that x minus alpha minus I beta is a factor of the polynomial, right? Factor theorem. It's still true for complex zeros, okay? And since they come in conjugate pairs, you also get x minus alpha plus I beta. All right? When we multiply that out, something really neat happens. So let's multiply it out. We get x minus alpha, let's think of that as a unit, square it. So I get this times that. Then I get plus, or rather minus I beta times x minus alpha. Then I get plus x minus alpha times I beta. And then I get minus I squared beta squared when I multiply out these conjugate factors. Now what happens there? Something really nice happens. These middle terms here, they're the same but opposite in sign. So these and these cancel. And what you're left with is simply x minus alpha quantity squared plus beta squared. All right, now what I'm using there, notice that this I squared, hey, ha! Well, all right, it came back to me. There we go. So here, I squared is minus 1, right? So minus a minus 1 is plus 1. All right, let me put this in other terms. That is, f of x is equal to x minus alpha squared plus beta squared times something. I'll call the other thing g of x. And this is actually, it goes both ways. All right, this is actually an if and only if thing. So what I'm saying is, if you have the formula in red, then f of alpha plus I beta is 0, f of alpha minus I beta is 0, and vice versa. If you have f of alpha plus I beta is equal to 0, that implies you have this prime factor of your polynomial. So this theorem is like super useful. This seems like it's in the way. There we go. Now we're all awake. I guess you guys were awake already. Example 1. So the top hat's been acting up in all your classes? Just this one? It knows I don't like it, doesn't it? All right. I mean, it's true. Oh, well, it caught me. So check this out. So if we have f of x, right, is equal to, you know, let's see here. X squared plus 6x plus, oh, I don't know, 17. Find two complex numbers for which, you know, f of alpha plus I beta equal to 0. So the complex number, I'm calling the complex number, I'm going to call it alpha plus I beta, okay? In fact, it's like that. Okay, so here we go. We start with f of x is, what is it? It is x squared plus 6x plus 17. How do I put it into the format of a square plus a number? I do completing the square, right? Complete the square, we have x plus 3 squared, all right? And then I have to do what? I have to subtract 3 squared, right? So I subtract 9. I still got my plus 17. So what's that give me? Plus 8, right? So then what you want to do, once you have that, and you know the theorem, right? If you know the theorem, then you can just pattern match. So what I'm saying is compare this versus what? Versus x minus alpha squared plus beta squared, right? If you look at these two, we can see what? Alpha equals to minus 3, right? And beta squared is equal to what? Equal to 8, right? So what are your choices for beta then? If beta squared is equal to 8, what is beta equal to? Yeah, plus or minus the square root of 8, right? So you could use either plus or minus 8. But anyway, the point here is, lo and behold, we find that f of, minus 3 plus I root 8 is equal to 0. And also f of minus 3 minus I root 8 is equal to 0. There you go. Now, could you guys solve this problem before you had this theorem? I think you could. I think some of you could. Because all I'm really asking here is, can you solve x squared plus 6x plus 17 equal to 0? Can you do that? It's imaginary, yeah. It's complex, right? 6x plus 17 equals to 0. What's the other way you could have found the solutions here? There's another way, right? You could have used the quadratic formula, right? You could have did minus 6 plus or minus the square root of 6 squared, which is 36, minus 4 times 17, which is, what's 4 times 17? 40 plus 28, 68, right? Yeah. Divided by 2, which is what? Minus 6 plus or minus the square root of, what, 36 minus 68 is what? 32, yeah? Negative 32, thank you. Over 2. So what we got is minus 3 plus or minus 1/2 times I square root of 32. Because the square root of minus 32 is I times the square root of 32. And then the square root of 32 is what? 32 is what? 4 times 8, right? So this is minus 3 plus or minus 1/2 of I times, well, 2 times square root of 8. The 2's cancel, and you got minus 3 plus or minus the square root of I times the square root of 8, right? Now, someone in the last section said the quadratic formula is easier than this. And I think that's true in a certain sense. If you already know the quadratic formula, and you know it deeply and confidently, sure, what I wrote on the right is easier because you already know it. But in truth, this is easier because all I had to do is compare this to that and I could read the number off. I didn't have to sort through the quadratic formula, right? You're like, well, you also had to complete the square. Well, that's true. You got me there. But you also need to learn to complete the square, you know, so. Yeah.
You're basically replacing all of the figures with the numbers included.
Right, yeah, so I wanted to make my theorem for like arbitrary figures. So this is true for all possible complex numbers, but for the specific example, we're trying to figure out what choice of alpha and beta the theorem is put into practice for. Exactly that, yeah. And listen, if you don't like alpha and beta here, you could make A's and B's. You know, if I made these alphas and betas A's and B's, would you feel better about it?
That's what I did.
That's what you did? I went to grad school in physics with some Greeks. I had a good friend, her name was Electra. She was from Thessaloniki. And Manuela was from Athens. And we would be like comparing homework. And I would be like, I got the answer of, like 3 3 alpha over 2 beta squared plus 1 or something, and they'd be like, I got, yeah, and it'd be like, yeah, it's the same thing I got. And I'd be looking at their work, and they had like 3a over b squared plus 1. And I'm like, you have a and b, you don't have alpha and beta. And they're like, they're the same. I'm like, no, a is not alpha, b is not beta. These are different symbols, but to the Greeks, like they just start, they start mixing them freely. It's not helpful. But for us, they're really radically different things. Like you don't see a alpha and beta as a and b, do you? So, but it's just Greek A and Greek B. And it's just, the reason I use alpha and beta here is because there are other formulas where I use like a big A or a little a, and I don't ever want to have a confusion between those and these. That's why I do this, that's all. So, anyway, that's good? Okay, so let's try another. There, sample 2. Let's see here. So consider f of x equal to x minus 3 times x squared plus 4x plus 10. Find, oh, I'm sorry, this is not what I want. My bad, guys. So sorry. There's some problems in your homework. Let's see here. Consider f of x equal, let's say, x to the power 3 minus, let's say, 4x squared. All right. Oh, fine. Plus 5x. All right. Calculate f of, let's say, 3 plus 2i. So I think the ones in your homework are actually a little bit easier than this, because I think the ones in your homework, they ask you to plug a complex number into like a quadratic. We're going to plug it into a cubic, just for fun, okay? Just to see how it goes, okay? So what does this mean? This means you put x equal to that and plug it in and see how that goes, yeah? So here it goes. F of 3 plus 2i is 3 plus 2i cubed minus 4 times 3 plus 2i squared plus 5 times 3 plus 2i. I think it's a good thing for us to stop and work out one piece of this before we do the next step. So like, let's work out the square of the complex number before we do anything more here. So, oh man, stupid power cord. It's trying to get out. Get back into, go back to, just unplugged itself. As this thing gets older, the power cord is less and less staying where it belongs. Anyway, okay, so what is, I'll work it out up here. What's 3 plus 2i squared? It's 3 plus 2i times 3 plus 2i, right? And that is 9 plus 6i plus 6i plus 4i squared. What is I squared? It's equal to minus 1, right? So you put that all together, what you got is you've got a 5 plus 12i. All right? So I can use that to simplify this a bit, yeah? So what I'm looking at here is 3 plus 2i times my square, right? So like 3 plus 2i cubed is 3 plus 2i times 3 plus 2i squared, right? And then I've got minus 4 times my 5 plus 12i again. And then I think we can just multiply out the last term, right? That's going to be 15 plus 10i. Do you guys follow what I just did here? Like lost the last class a little bit on this one. Check this out. It's like if you're calculating 5 cubed, how do you do it? I think about that as 5 times 5 squared, right? What is 5 squared? Well, 5 squared is 25, right? So, I mean, we do it in stages. So the same thing here, like 3 plus 2i cubed is 3 plus 2i times 3 plus 2i squared. But 3 plus 2i squared, I worked out over here to be 5 plus 12i. So that's a way to break down the cube into 2 steps, you know? Nothing terribly profound going on here, and now we have to FOIL it out, okay? So the way to do complex arithmetic is just like regular arithmetic. What's the big difference? The big difference is that I squared is minus 1, but otherwise, just the same. You just multiply out distributive law, same as before. So we've got 15 plus 36i plus 10i plus 24i squared. And then I've got minus 20 minus 48i plus 15 plus 10i. All right. Now, before I do the simplification, what do you guys think? Is this going to work out to 0? Yay or nay? Nay. Yeah, probably not. I mean, odds are against it being 0, aren't they? And I think you're right. I don't think this one's going to work out to 0. So I squared is minus 1, right? Okay, so let's put it all together. What do we got? Add all the real parts together. 15 minus 24 is 9. Wait a minute, minus 24. Minus 9, right? So 24 minus 15 is 9, so this is minus 24. So minus 9 minus 20 is minus 29. Minus 29 plus 15, I believe, is minus 14. So we get a net real part of minus 14. What about the imaginary piece? 36 plus 10 is 46. 46 minus 48 is minus 2. Minus 2 plus 10 is plus 8i. So there you go. I think the one in your homework is much simpler than this. They just gave you a quadratic, right? And they asked you to plug the complex number into that and figure out what it works out to. But this is a more complicated version of that calculation, all right? Now, what complex number would make this 0? Ask that to you guys. What complex number would make this 0? Would that be a reasonable quiz question? Find a complex number which makes this cubic 0. I would argue that that would be a reasonable quiz question after I do this example for you, not before. So since I'm doing this example for you, I think it becomes a reasonable question. Without this example, I think it would just be mean-spirited. So look, this f of x we can factor, right? How does it factor? If you've got an x on every term, you can pull it out, right? So we factor the x out, and what are we left? X squared minus 4x plus 5, right? Then what? Then, yep.
Wouldn't it be just x?
Oh, thank you. Thank you, thank you, thank you. Yeah, I don't know what's wrong with me. Well, many things, but yes, thank you. Other comments, corrections, jokes? Yep.
X minus 5,
X minus 5, X minus 1.
Can you break that down?
X minus 5, X minus 1. If we multiply that out, we get x squared minus 6x plus 5. Ah, curses. Good try, but no. Search your heart, all of these things you're trying will fail. Eventually you will be driven to complete the square. So we do x minus 2 squared minus 4 plus 5, which gives me x times x minus 2 squared plus 1. So what complex number makes this 0? 2? Let me, if you don't mind me working manga style here a little bit. I'll go over here. So I got this formula, right? F of x equals to x times x minus 2 quantity squared plus 1. That's my formula, right? Let's try to put in a certain complex number into it, see what happens. What complex number should we try? Two I? That's about right. How about we try 2 plus I? Let's try that. Let's try 2 plus I. Why would I try that? Because if I look at this and I compare, right, if I compare x minus 2 squared plus 1 to x minus alpha squared plus beta squared, what does it tell me? It tells me that alpha should be 2 and beta squared should be 1, right? Which suggests to me I can make beta equal to 1 as a choice. So I should try 2 plus I. That's alpha equals to 2, beta equals to 1. Let's see if it works, you know? Plug it in. We get 2 plus I, right? Times 2 plus I minus 2, quantity squared, plus 1. What happens then? We get 2 plus I times what? The 2's cancel. And we get I squared plus 1. But what was I squared? I squared is negative 1. That's 0. Right? So this is minus 1. So this is altogether 0. So what I'm telling you is that there is a one-to-one correspondence between complex zeros of a polynomial, right, and factors which are prime. To each prime factor, there corresponds a pair of complex zeros. This one, you see the calculation would have gone pretty much the same. You could also see that f of 2 minus I would also be equal to 0, right? All that would have changed is you, instead of getting I squared, you get minus I squared. But that's still I squared, because the minus gets eaten up. You still get 0. They always come in conjugate pairs. So there's a subset of your homework which is testing you on understanding this theorem. Complex zeros come in conjugate pairs, and they're always associated with these irreducible prime quadratics. And yeah, we can use the quadratic formula to find them, but you don't want to have to do that. You want to understand this interplay, right? Let me show you a non-trivial example. You'll give me a second here. I have to create it over here because it involves doing a multiplication of 3 things by another 3 things, and I don't do that in my head because, you know, if I try that, it goes badly. All right, let's see here. All right, here we go. What example? I'm on example 3. Yeah. Let's see. Suppose f of x is equal to x to the power 4 plus 12x cubed plus 54x squared. Oops. 54x squared plus 108x minus 175. All right. And a mathematician tells you that f of minus 3 plus 4i is equal to 0. Factor f of x completely over the real numbers. So how are we gonna tame this problem? What do you guys think?
With some long division.
With some long division. Wow, that was fast. Very good. It took my other section like 3 minutes to tell me that. So that is good. Now, why do you say long division? How do you, I mean, how? Long division of what, though? What's a factor? So we need to use this theorem again, okay? So what's the theorem tell us? The theorem tells us that each complex zero corresponds to a real prime factor. So here's the deal. Since we have f of minus 3 plus 4i equals to 0, that tells me that alpha equals to minus 3 and beta equals to 4 for my theorem, right? And that tells me in particular that x plus 3 squared plus 16, which is 4 squared, right, is a factor. Now if I square that out, that gives me x squared plus 6x plus 9 plus 16. So in short, we have a factor of x squared plus 6x plus 25 for f of x, yeah? Let me put that in more concrete terms. That means that we can write the above up here as equal to x squared plus 6x plus 25 times something. Now, can you guys just tell me what goes in the parentheses I wrote up at the top of the board? I can do 2/3 of it. I can always do 2/3 of it. Like I'll do the easy. Here's the low-hanging fruit. There's an x squared here for sure because x squared times x squared has to give me this x to the 4th, yeah? And in order to get 175, I need to multiply 25 by something to get minus 175. That's a minus 7, right? But that's where the easiness stops. Like, what do you put in the middle here? That's not at all obvious. All right. How do we do better than that? Long division, right? So we're going to divide. Let's see, we're going to divide. What we got here? We're dividing x to the power 4 plus 12x cubed plus 54x squared plus 108x minus 175, right? And what do we want to do? We're trying to divide x squared plus 6x plus 25 out of that thing. All right? Okay. Mm-hmm.
Is the stuff on the right of the, so the x squared, or x plus 3 squared plus 16, the stuff on the right of that, x squared plus 6x, is that just the first part of the FOIL values?
Oh, yes, yes. Thank you. This right here is precisely those three terms. I just multiplied it out. Good question. So how does my long division start? I want to get this x to the fourth, right? So that I got to put an x squared up here. X squared times this gives me x to the fourth plus 6x cubed plus 25x squared. I then subtract, and that gives me 6x cubed. 54 minus 25 is 29? Is that right? 29? Yeah, okay, 29. Plus 29x squared. And then I bring these things down too. Now, some of you don't bring those down, and you like leave these up here for later, whatever. If you have a slightly different notation for long division, but you still come to the same answers that I do, that's fine, okay? If you're like, I love the book deeply, I want to ignore you and study the book because I trust the book more than I trust you, nothing personal, but I just like the book, and what you're doing right now seems really hard, and I'd rather do synthetic division with two complex roots and then put it all together. You can do that, but please don't. Like, please don't. So the book doesn't do any of this long division stuff, right? The book uses synthetic division with complex zeros, but you know, each one of these kinds of divisions corresponds to a division by two linear factors, each with complex roots. Like you have to divide by, well, let me not even write, let me just say it in words. You have to divide by two complex linear factors. So it would be two synthetic divisions, each one with complex numbers, in order to achieve what we're doing with this one long division. With no complex numbers, right? No complex numbers here, except for where? Here, right? After that, we find a real polynomial to divide by. It's all real. All right, let me stop complaining about the book. I'm not complaining, I'm just warning you that if you go to a tutor who insists on using the book and ignoring what has been done in class, then they're going to lead you astray and waste your time. Yeah? So that's a danger. So plus 6x, yeah? You think 6x? Is that right? 6x. So if you're a real minimalist, at this point you realize I could stop writing and just put a plus 6x up here and be done. You know? Because, but I'm going to keep going and finish this calculation. So we get 6x cubed. 6 times 6 is 36, yeah? So plus 36x squared. 6 times 25 is 150. 150x. Yeah, subtract these deals. What do you got? It's a good thing to keep going too, because if you keep going and you don't get a remainder of 0, something went wrong, which means there's an error somewhere, but hopefully that won't happen to us. 29 minus 36, that feels like a minus 7. And 108 minus 150 is minus 42. And minus 175. There we go. So then what's next? We do minus 7, right? So I do minus 7 times that, I get a minus 7x squared. Minus 7 times 6 is minus 42x. Minus 7 times 125 is minus 175. Phew, that's a relief. So the remainder is 0. All is well. It really is a divisor like that. Have we finished the problem? Not quite, right? So I'll write it down here. We have f of x is x squared plus 6x plus 25 times x squared plus 6x minus 7. The instructions were to factor completely over the reals, right? So one of the things we know from what we've already discussed here is that this piece is prime, right? Because it comes from the pair of conjugate zeros. Yeah? But can you guys factor the other one? x plus 7, x minus 1. I didn't hear him the first time, so I can't be sure, but the second time sounds okay. You may say the same thing twice, so
I
don't know.
sign this
Oh.
negative 7.
But I think that's it. Now, that's completely factored over the reals, all right? Now, what if instead of it said, what if this question said, factor completely over the complex numbers, then what will we do? I haven't really talked about that much, but if instead you wanted to factor over the complex numbers, it's not much more complicated. So this is really, this right here is x plus 3 squared plus 16. So going back to the theorem, this factors as x plus 3 plus 4i times x plus 3 minus 4i. And you got this x plus 7 times x minus 1. It's like any time we have generic comment, if you ever have x minus alpha squared plus beta squared, you can factor that as x minus alpha plus I beta times x minus alpha minus I beta. That's how that factors. And that's exactly the calculation I did over here. I just in reverse. The proof that that's true is over on this board still. So that's all I did here. I had x plus 3 squared plus 16, x plus 3 plus 4i, x plus 3 minus 4i. That's how it factors. Now, I don't usually ask for complex factoring because I don't like everyone to get the problem wrong. And I know you guys are uncomfortable with complex numbers, and I don't try to rub it in too much. But it is part of the course, but it's not a big part of the course. So just be aware that if I do ask you to factor completely over the complex numbers, that means that everything will split into like linear factors. Every quadratic will factor if we use complex numbers, right? In reals, if the factoring is over the real numbers, there are these quadratics which cannot be factored, right? They're called primes. They correspond graphically to like parabolas that don't have x-intercepts, right? If you look at y equals to these prime factors, it is either opening up above the x-axis or down below the x-axis in such a way that it never hits the x-axis. That's why there are those things. But anyway, that's that. Any questions? Yeah. Oh, this? Oh, okay, fine. Let me go through it. So what we have is we've got x plus 3 squared plus 16, right? If you don't mind, let me just focus on that piece of it. All right? Can I just focus on that piece? Okay, so we have x plus 3 squared plus 16. We can rewrite that as x plus 3 squared minus 16i squared. Because minus I squared is 1. But a better way to write that is 4i squared. See, because minus 4i quantity squared is minus 16i squared, which is minus 16 times minus 1, which is 16. All right, so I'm just rewriting 16 as minus 4i squared. The reason to do that, go back to day 1, what's the first thing we talked about? Difference of squares formula, right? So this is a squared minus b squared, so I use a plus b times a minus b. See, this is my a, this is my b, this is my a, this is my minus b. And the pattern is a squared, so that's why there's a 4i there. But the simpler answer to you is I'm just referring back to this theorem yet again. Yeah, what was your question?
So like you had alpha equals -3. How did you get the positive 3 for x plus 2 squared?
How did I get the what?
I feel like look at the top where it's like alpha.
Well, remember it's alpha, it's x minus alpha in the theorem.
Yeah.
So you're really,
Is it minus?
so yes, it's the minus issue. So like here, right here, okay, so this is the x minus alpha plus, it's exactly the same issue as, you know, we have f of c equals to 0 if and only if what? X minus c is factor, right? So like, where'd the minus come from? It's because here we're talking about a factor, whereas here we're talking about the number that you plug in to make it 0. So next time, guys, what we're going to do, we've got 5 boards in here, right? So I'm going to break you guys up into like 10 groups, all right? And each group is going to work on a problem on like a half board, all right? For maybe like the first 20 minutes of class, something like that. And then I will send you guys back to your seats, and then I will critique your work and decide whether or not the work survives. And we'll all decide together how wrong each other's problems are, right? And no, they're all going to be correct.
They're going to be hard problems.
They don't have to be hard, but so something will be wrong. I will criticize. I will make annoying comments about the handwriting being ugly or something like that. You know, I'll make. All right, let me turn my camera off before I forget. It's all good?